Probably this case some big section and govern somehow. I don't know why it choose 821. What I think we could do is within our based on that calculation, 18 by 40 also works. Okay. So I think this case, this is kind of the ETABS give us the some features. So as far as we understand that grouping, I think now is all engineers call. So I have a more freedom because the ceiling height and the docks, all those relationship is critical. I just structural engineer. I prefer to use 18 instead of 21. Obviously, both are all working members, but I choose 18 by 40. Some E-types, even though show few beams, 21 by 44, for some reason, you could just override it, right? This now is engineer judgment. I don't want to differentiate it, especially those, because they are same conditions. So I choose all the beams in the group. I just override it. I'm gonna use 18 by 40. So uh, on the plan, you can see all the beams 18 by 40, and maybe we could change this patterns. Maybe because this pattern ETABS chose because of this small divider beam. I think so. So you see that instead of this majority of beam has a uniform spacing stud, but this beam, because of ETABS recognize this divider beams right there, so they just chose a pattern spacing, which is okay. Or sometimes we don't even have to draw these divider beams. Instead, because it doesn't take the gravity loads. But eventually, practically, those divider beams only just for stability, right? I explained that. So those beams not necessary to touch the concrete slab or metal deck, because that beam has to be lower, located just a few inches below that slab. So I try to explain that typically we need some stabilized beams, but those beams, stabilizing beam, don't necessarily to be on the floor framing model. Um, since we add those stabilized beam, I think ETABS recognize somehow beams exist, and they just choose the pattern pattern of for the stuff. So anyway, that's not a big item, just general. But you could see that 18. I choose 18 by 40, right, for all, and then majority is 20, 36. Only just few beams, 26. We'll just experience. We'll think that we're gonna take a look at it. I don't know why, but in this case, even this, I'll more prefer to use the same number of studs. Don't have to differentiate this. So let's see. Oh, there is 22 because I override it. Run it. So now what we're doing is we finished the geometry analysis design, but after design, I think engineers has to make a judgment to group it based on the experience, more practical experience. there may be the ETAPS is not always perfect, or looks like everything is line up, but in reality, in deep inside, is some geometry may be not perfect, 100% identical. So you may have some slight different uh, output. And still, you choose 21. How can I overwrite? Maybe. And I can select. Maybe because I'm gonna select one group and assign. I'm gonna overwrite. Maybe beams. The beam. Oh, maybe there we could play with the criteria for a maximum. Perhaps is 18 or okay. Here, change design section to we could change 18. Since we know that 18 by 40 works mostly, let's see how it has recognized the beam I use, override beams. Did I select? Did I select group? Ah, 56 study. Go design, composite beam, and change beam design section. Right. Uh, oh, okay. Maybe not. Move inside. Wait a minute. Looks like I'm opening all beams calculations. Oh, okay. So instead of okay, I'm gonna choose 18 by 40. Override here. So since we are using a group, so it has choose the biggest section for this group, right? And the group that's fine. Okay, maybe since then you could specify the beam and then assign the W18 by 40. So at the time that we are doing some grouping, I think we could choose all the beams and we analyze it. Design it. So here, just do some manual grouping. So engineer use their engineering judgments. We just we select that all the beams that I'm gonna use W18 by 40. Okay. So far so good, right? So now, okay, safe slab study. Okay, I think this is something I have to clear one more time. Because the safe is only for the concrete slab, way slab, 1A slab, not composite slab. So for current all the framing composite beam, you don't need a safe analysis except only mat foundation. Maybe not this week. Next week I'm gonna show you how to create ETAP foundation model. I'm gonna show you the introduction of how to create mat foundations. But it's pretty similar to that two-way slab uh, uh, the walking floor. Last week I show how to convert each floor slab from ETAPS to convert ETAPS to the safe. Similarly, the mat foundation or foundation design, we need all the output column reactions from ETAPS. Those are all the output we need to convert, transfer those data from ETAPS to safe. Then we drew the mat foundation on it safe. So at this point, because this is composite floor framing, you don't need to create any safe for framing. And a column design load, okay, column. So now I'm just try to clarify here. So let me just open that Excel spreadsheet. Okay, so we have many tabs, but for first of all, column design. So we have to do the column load takedown. I think you did. You understand the tributary area, right? So 40 feet by 30 feet, which representing interior column. So we have a 40 feet. Maybe I can draw that. Don't get confused. This is column we are interested in now. The grid system, we have a 40 feet and 30 feet. So this is, let me see. See? So, so those area, which we call tributary area, all the loads on this zone goes directly to this column. So this is just column node takedown and associate tributary area. And the column on the edge, obviously, those are all based on their adjacent bay dimensions. So for this column, take the half bay, another half bay. So you could just draw that rectangular shape. So those are tributary area for this column design, right? So this one is like this. You could see the corner column is small like this. Edge column, same thing. Those are all. So those column uh, uh, has to design for that tributary area and associated gravity load, right? So go back to your spreadsheet. You type in 30 by 40. I think showing that you're interested. The column design for interior column has a tributary width. One side is 40 feet. The other side you have a 30 feet.